This is Algebra 2, lesson 49 on page 213. Linear intercepts. All right, so two names to this lesson, 2 words. Linear intercepts. All right, what does linear mean? Say it, Sarah. It's a line. That's correct. It's a line. It's the only one that has an equation that's a line. What are the variables in a line? Can you give me like one of the forms of an equation for a line? Therese. Right. How many variables?
3, 4.
Well, what is M? Slope. And what is B? So we only have X and Y as variables.
Yeah.
I know here we have all letters. It looks like 4, right? But really, it's 2 variables. Both of them are raised to what power? The first. That's always a linear equation. 2 variables. It's a line, right? It's a straight line. So it goes infinity to negative infinity all the way to positive infinity. So it goes in both directions, opposite ways, never ends. All right, so it's a line. What are intercepts? Where line, yes. Okay, y'all remember the term in geometry? Do you remember where lines are? You know, it's a C word. Concurrent. Right. Okay. So it can be where lines are concurrent. So like Michael said, that or this, right? Okay. Are there any other And actually, okay, I'm going to sort of separate a term here for you. I'm going to say this is where they intersect one another. And differentiate it from an intercept in terms of math. Okay? So this is where 2 lines intersect. But intercept, we have 2 of them. We have x-intercepts and we have y-intercepts. So now, what do you think it is? What do you think an intercept is? It's where a graph crosses the x or the y axis. All right. All right, so is everybody listening? Every equation has every function has one and only one y-intercept. If it is a function, there will be one and only one y-intercept. If it is a function, the number of x-intercepts is dictated at most, do y'all remember, by the degree of the equation. By the degree of the equation. So this equation is a first degree. So how many x-intercepts am I going to have? 1. If I had, I can have 2. If this were x cubed, I could have 3. That is at most. Therese? Huh? At most, this dictates I could have 1. I could have none. With a line, I'm always going to have 1, 100% of the time. So this lesson is about lines, and really it's about the y-intercepts. Because we have come up with equations from graphs and we have seen the y-intercept. Look at the bottom of page 213. You see those two graph lines? In the graph on the left, you see the y-intercept. It intercepts the y-axis at 2. So that you know this b value here is going to be plus 2. This lesson looks at the graph on the right. Can you tell the y-intercept? You cannot. So the y-intercept is not going to be visually evident. So you have to solve for the y-intercept. Okay? All right. So when we have a line, you cannot tell its y-intercept. All I need is 2 points, 2 coordinate points to come up with the equation of a line. So looking at that graph on the bottom right, what are 2 obvious, clear and evident points that I can use to come up with the equation? Bottom of page 213, bottom right. What is 1? Evie, do you see 1? Okay, I'm just going to give you a big hint. I always go to the end of the line. It's so obvious at the end of the line. Don't try to find one in the middle. If you go to the ends of the lines, and that's with Saxon, that typically works. And in most textbooks, that works often. All right, so Evie, what would be 1 point? A coordinate point. So an X and a Y, right? Okay.
4, 6.
It's not 4, 6. It does. My x-intercept is 4.
Oh, 3, 6.
3, 6. Okay, so one is 3, 6. Dylan, what's the other one?
4, 0.
4. Okay, I could use 4, 0. It's not at the end, but it's an obvious point, right? I could absolutely use that. All right, you begin first by calculating the slope. Calculate the value of the slope. What's the formula for slope? Slope equals change in y over change in x. So I'm going to do 6 minus 0 over 3 minus 4. See that? The change in x over the change in y. You could label them x1, x2, y, x1, y1, x2, y2. Plug it into the formula. If you need to do that, do it, right? So that's 6 over -1, which is -6. Was I expecting a negative slope? Look at the line. Yes, I was. It falls from left to right. Now, to come up with the equation of the line, what formula do you think that I would use? Jaden, what do you think? Jake. I want to come up with the equation of a line for that line.
I don't think I did. I didn't do it the same way, so I don't think I'm on the same path.
Okay, what do you think, Jesse?
Slope.
Yes, point slope. What's the point slope? Y minus y1 is the slope times x minus x1. I have the slope, I have a point. I'm obviously going to use the one with 0 in it because then I don't have to add or subtract anything, right? I mean, that's what I would do. It doesn't matter which one you use. You're going to come up with the same answer. The slope is -6 times x minus 4. This is just y. Distributing the -6, I end up with -6 plus 24. Is it reasonable to look at that line and think that my y-intercept is at positive 24?
Sure.
Yes, it's reasonable. All right, so I always, when I work problems, engage my brain. So do you see, this is not much different from what we've done. The only difference is the y-intercept is not evident. All right, the second part of this lesson goes back to geometry, but we will work the example. All right, so turn the page and look at 49.2. Just to remind yourself of geometry. We have a right triangle. We're given that length. We don't know what that is. They're looking for angle A, the length of M. They're looking for B. This is 158 degrees. All right. Which would you solve for first? Michael, what's B?
22 degrees.
It's 22 degrees. Explain to me your logic.
Because they're
It's an S word.
they're supplementary.
Supplementary. That's right. Because they're a linear pair. They're a linear pair. You remember that? Linear pair, supplementary. All right. Where would you go next, Nora?
A is also 22 because they're corresponding.
Yes. A is also 22 degrees because they're corresponding angles. Now, Will, where are you going? M or N? And how are we getting there? Exactly. We're using trig. The sine of what? Equals n over 90. How do I solve for this? Multiply by 90. Okay, so everybody needs to do this in their calculators. What's 90 times the sine of 22?
33.71.
Say that one more time.
33.71.
That's what I thought you said. But I couldn't tell if 33 or 32, actually. Let's make sure everyone can get 33.71. Everybody good? Okay. Therese, how are we going to solve for M?
Then you could do the cosine.
Exactly. I would do the cosine of 22 degrees equals what? M over 90. Then just multiplying both sides by 90. Everyone do this, Therese. Tell me the value of M. 83.44. Are those values reasonable? Why? Why do you think they're reasonable?
They're both less than 90.
Exactly. The legs have to be less than 90.